Thank you all for making it this far. I hope you're enjoying the hospitality. But we've got one session left of talks. This is the session of things we didn't want you to miss. We've saved the best of our speakers on a diverse range of topics, many threads in our tapestry, to this point in the meeting. Without any further ado, let me introduce the first of them. I'm really pleased that we're joined by Arpita Roy. She's an astronomer by training, spent some time here in Oxford, but we'll give most of the credit to her time at Caltech and Space Telescope elsewhere, where she was heavily involved in searching for planets, working on instruments like the Keck Planet Imager. But she's here today in her role as head of the Astrophysics and Space Science Institute at Schmidt Sciences. So I'll hand over to you, Arpita.
Thank you. It's a pleasure to be here to represent a friend philanthropy of Breakthrough. We've heard a lot of both optimistic and kind of scary things about the future of space exploration, so I'm going to try to put more of an optimistic spin on it and tell you about the different options we have really for the future and the kinds of risk we might take on. Oh, do I have the clicker? Oh, that's right. Okay, so I titled this Build Fast and Launch Often because sometimes when I ask astronomers how we change the field, that's the answer we get. So let's see what that might look like if philanthropy was to take on some of that role as complementary to the traditional funding sources that we've mostly been focusing on the last couple of days. So a little bit about me. I'm currently the lead of the Astrophysics and Space Institute at Schmidt Sciences, and I'll tell you a little bit more about Schmidt Sciences in a minute. I am an astronomer. I've been in academia until this position, and I study exoplanets, so I build extreme precision radio velocity instruments to search and characterize planets, and I was also one of the JWST commissioning scientists. I also spend quite a bit of time thinking about the community, and this role actually helps me do both of those things, make science happen, make scientists happy. So I'll start with this statement about the history of astronomy's interaction with philanthropy, which actually goes deeper than many other sciences. And at least in the US, science philanthropy has actually played an integral role in developing the R&D culture of the country, and you see some of that reflected in many other countries. The US actually spends less money of its GDP on research than many other first world countries. So I'll show you this graph to kind of explain how philanthropy has evolved and alongside other funding mechanisms in the last few centuries. The font got a bit messed up, but so we start in colonial America in the agricultural age. In this time, science was a hobby, an avocation, practiced by people like Ben Franklin and Thomas Jefferson. Universities at this time were mostly religious, and philanthropy also tended to be very religiously oriented. There were some research universities being developed in Europe, in Germany especially, but in the US, Harvard, Yale, Princeton, et cetera, existed, but they were not as scientifically oriented. From there, we move slowly to the industrial age. It starts in Britain, spreads to the US, and for the first time, individuals start to build wealth in their lifetimes. And there starts to be a culture of giving away that wealth in their lifetimes as well. Andrew Carnegie famously said that a man who dies thus rich dies disgraced. And it started this trend of giving away money into scientific and technical innovation. Because it was the industrial age, there was less kind of pure science research and more technical innovation that was happening. But these were the barons of the Gilded Age, right? There were the railroad barons and the oil barons, and just huge fortunes that were being endowed that we still benefit from today. Then comes the war, the Second World War, and From that emerges the manufacturing age, and at least in the US, this is when the federal government really gets into science funding. So there's this very famous Vannevar Bush report where he really encouraged the government to invest in science, but to do that science research, this was critical at the universities. And it changed the culture, and this is really when the US started to find a lot of success in its scientific innovation. But as a flip side, philanthropy reduced its support because it imagined that this was now the government's job. So we move from there to the current age, the digital information age. And there starts to be a second gilded age of individuals making great amounts of wealth. And science philanthropy has reemerged from people who've made their money in finance, in tech. And similar to Carnegie's statement, there was the Gates-Buffett pledge that echoed this same sentiment of giving away wealth in their lifetimes. And I think actually Breakthrough is a product of that pledge. And so science philanthropy reemerges. This was not to mean that federal funding should decrease, but coincidentally, those two seem to stay kind of a little bit opposed to each other and when they swell and fall. So the association of astronomy with philanthropy, of course, goes back a long ways. Many of our telescopes are built with philanthropic, often going way back, aristocratic funding. So I wanted to ask you, and you should just shout it out, tell me some names of your favorite facilities that you know have philanthropic funding. Keck, yes. Yes. Sloan, yes. What was that? Reuben? Yes, even the new ones, yes. Like, yeah, even the old telescopes at Palomar, the TMT, right? Kind of looking at the whole history of astronomy, there's been a lot of engagement. So this is not something new. Sometimes people ask me what a science philanthropy is. Each philanthropy tends to be different, and so it's hard to describe them succinctly. But a good way is to look at the Science Philanthropy Alliance, which many of us are members of, that kind of tries to gather forces and somewhat coordinate them. Philanthropies are, I think, resistant to being told too much what to do, but this is a good way for everybody to talk to each other. So you'll see several foundations that you've probably heard of, associated with astronomy or not, that are in the space. So philanthropy brings a lot of unique advantages to this space. Some of these, for those of us who are in philanthropy, are very obvious, but I'm going to call them out just because it is different than federal funding. So I think one of the biggest advantages is that it is up to us if we want to embrace risk. So our risk postures are set completely internally by small groups of people, and usually our founders are okay with, high risk, high reward schemes. We can move funding fast, right? We're not beholden to government cycles. We can have a very light touch with our grantees if we want to. There does not need to be a lot of reporting. There can be a lot of trust, and if the research needs to pivot because you tried something and it didn't quite work, we are okay with science that doesn't have immediate benefits, but in the long term elevates humanity. We can focus on high-risk science. We can transcend national boundaries. We can kind of shape the funding experience to be what we think is best, which is a lot of capability to affect the space. So you might ask, what are philanthropies doing today? We are at an event showing what philanthropies are doing today. But the Science Philanthropy Alliance published this report last year that tried to, for one of the very first times, give an overview of what was happening using data from the NSF. And it turns out philanthropy fuels almost as much basic research as government funding does. This is in the US, of course, but it's not much different in many other places. So some of the main findings of the report were that, and this will not surprise you, R&D is a small slice of the pie in general. In the US, federal funding has declined a lot, but philanthropic funding has increased. There is, of course, not a way to control that increase, but we should make hay while the sun shines, essentially. Biological and biomedical sciences tend to have a lot of philanthropic funding. Things like physics and astronomy tend to be quite niche. Philanthropy can make a big difference in smaller fields. We've seen this at Schmidt Sciences in ocean research. And philanthropies can be very effective if and when they choose to work together in affecting change in the culture of the field. So let me tell you a little bit about the foundation that I work for, Schmidt Sciences. Schmidt Sciences in its current form is only a few months old, although we've grown out of some of the other philanthropic experiments that Eric and Wendy Schmidt have conducted. We have 5 focus areas: AI, astronomy, biosciences, climate, and a cross-disciplinary institute. We have many different funding mechanisms. It's actually hard to describe the full portfolio of what we do, but I'll highlight 2 major strategies we use. One is to do short-term focused interventions on pressing issues, so things that are ripe for solution, technically, intellectually, but don't have the resources, and we call those virtual institutes. So there's several for climate, there's one for biosciences, there's one for astronomy. And the other one is making a long-term bet on people, and that's giving fellowships and awards. And we have, half a dozen fellowships, several of which are probably relevant to people here. There are AI fellowships for postdocs. There's a Polymath Prize for young faculty members. There's Science Communication Awards. So if you haven't heard of any of those, go to the website and see if you might be eligible to apply. And in thinking about astronomy, a question we ask is there a crisis in space science? Space science has been a frontier, right? Forcing us to push technologies in extreme environments that is not necessary on Earth, but has had huge consequences for our day-to-day living. But this need for success, visible success in the traditional funding agencies, tends to lower their risk appetites. And sometimes that ends up resulting in us not flying our best ideas, but the ones that are best poised for success. And there's an important difference there in how the future looks. And so as the community turns towards these mega projects that need to bring every astronomer's dreams along with them, naturally it takes us decades to build these things, right? We're asking for the impossible every single time. And so is there a place for a complementary approach that needs to exist? The federal agencies should perhaps take this lofty, ambitious, exotic approach, but is there another pathway here where we fly technology that exists now, and we don't wait a decade to do that? And so just to show you kind of how the time and cost curves are increasing, here are published NASA numbers on some of these space missions. And if I take away some of the little ones, you can see there's a curve you can draw there with your eye, and it's not great for what comes after HAB Worlds, and maybe not even HAB Worlds, right? That's waiting a very long time for the next big thing. So our challenge to the community is, can we change the pace of astrophysics? Because we think if we do more of these, we do them more often, we end up doing more science overall. So we want to drastically reduce the time and cost capabilities. This means taking risks, flying imperfect, not completely tested technology, blurring the lines between ground and space, buying off-the-shelf things from companies, right? We want to embrace risk massively, so we want to encourage experimentation, let failure occur, and learn from those things. And we are subfield agnostic, so we haven't picked exoplanets over galaxies, because as a philanthropy, as an astronomer, I have opinions, right? But as a philanthropy, that doesn't make a lot of sense. So we want to build platforms that enable many different kinds of astronomy, both hardware and software platforms. So the part of that build fast, launch often that isn't said in the sentence is that means sometimes failing. And what does it mean to truly accept risk? Because even philanthropies care about what their success rate looks like. So there is an art to defining your risk posture. There are a lot of examples in the field, and so we take kind of the pieces of those and try to execute fast. We also try to have a sensible risk management approach, which is a custom approach, right? Sensible risk means different things to different people. So this means small teams moving fast, skipping a lot of steps when everybody agrees that those are well enough known that we can move on. And the other word that's missing here, but is implied, is iteration. So you don't get these in one shot. You try several times, and you expect some level of failure, but in the end, you still get there faster. So I'll show you some of our projects to kind of give you a taste for the astronomy we're already doing. But I'll say this is really left over from our journey before Schmidt Sciences started. So Schmidt Sciences is almost a blank page to think about what else we want to do. So here's one of our software platforms. It goes with Rubin, LSST. It's called Link Frameworks, and it's part of the LSST Alliance. And the goal here is that NSF provides some money for software, but I think most of us who have received NSF money will agree that we could have used some more, right? And so this is that extra layer of gloss over the basic functionality that NSF provides, and this is an ML-driven layer that multiplies the science yield, works with the community, so they're providing research software engineer support, and they're building these tools that they're training the workforce on ahead of commissioning data, which will be coming very soon. Here's one of our observatories. So this is a hardware platform. This one is called DSA 2000. If you're in radio astronomy, you've probably heard of it. This is being developed at Caltech. We funded the build of that prototype, and we're helping them figure out what the next stage looks like. So this will be 2,000 5-meter radio dishes spread across Owens Valley in Nevada. And again, this is cheap and fast. So they figured out how not to be cryo. They have quite cheap, innovative parts. For example, one of their transmitters is a cake pan made by a company called Big Daddy-O, not kidding, that you can buy in grocery stores. And they're trying to solve this problem of the UV plane deconvolution by having extreme coverage on the ground. And so this means they actually produce radio images in near real time, which changes the cadence with which you see the dynamic radio sky. Another of our missions, this one is a small space observatory called Morningstar. And I think the PI just arrived, but I don't see Sarah. So this is PI'd by Sarah Seeger at MIT. This is another example of this kind of university-private philanthropy partnership. So it's trying to return humans to the atmosphere of Venus after almost 4 decades. It's a small probe that will fall through the atmosphere of Venus and slowly destroy itself. So it has a lifetime of about 5 minutes in the 48 to 60 kilometer altitude that it wants to study. It has a single off-the-shelf instrument called an autoneflometer that basically studies the scattering profiles of the molecules around it. And we've talked a little bit about onboard computing. Here, the data relay is very challenging, so it sends back a very small amount of data, and a lot of decisions will probably need to be made on board. When you speed up your development scale, these problems come closer as well, so this one needs to be solved by next year, and if it doesn't, we'll see what impact that has on the data. So we're also thinking about future pathways. Those are all projects we're carrying over that we will probably see through, but what else could we be doing? So we recently held this astrophysics and strategy retreat with some experts in the US. You might recognize some faces in that crowd, including our host. And to be fair, this was a North America-focused one. We do hope to have more of these. The next one will probably be in Europe. To just hear unconstrained ideas on what is important in astrophysics and what we could do. I will say we like to do big things, not lots of little things. But astronomers have a lot of great ideas for big things. Not often do people ask you what you would do for, almost unconstrained resources. But even asking that question, I think, unlocks a part of thinking that is often shut down by grant cycles. So one of the reasons I'm here is to listen to all of you as well on what is important, and we've been hearing a lot of great things, and also hearing about a lot of great things that are not possible at the moment, and that's what's really interesting to us. And I'll stop there, but you can ask me lots of questions for the rest of the day. Thank you.
Thank you.